For Lesson 8.1, just notice the title. Hopefully you're picking up on all the vocabulary words that are being used throughout the different chapters in your textbook and how that helps you understand what we're going to be doing in each lesson. So we're going to be solving. We spent a great deal the first part of the year simplifying and evaluating, but now we're actually going to be solving equations. And so remember, equations have the word equal, most of it anyway, in it. So these are going to have equal signs, and we're going to be finding the value of x. And those variables have a rational coefficient. So that means in front of the x we have numbers like 3, or maybe a negative 7x, or even 4/7 x. Those are all rational coefficients, and we're going to be solving them. As soon as we have an equal sign and a number on the other side, we can solve those equations by doing the inverse operation. So lesson 8.1, you have your what you'll learn, and if I scroll down here, one way to solve equations is by dividing, and this shows you an example right there. And notice right here we have 3/4 times a number is equal to 72. Well, to isolate the variable, we are going to get rid of this 3/4 by dividing by 3/4. But that looks a little bit different to have 3/4 x equals 72. And when you divide by 3/4, it looks a little bit different than a way that is usually a common way of showing your work on these. This isn't wrong, it's just a different way of showing your work that maybe is not as common. Could you divide by 0.75? Could you change that to 0.75? Yes, you could, but I'm going to show you the way that I was taught, and I'm not saying it's the only way, but a very common way teachers will teach it because that's the way that makes sense to them, but know that there are some different ways. So dividing by 3/4 is the same thing as multiplying by the reciprocal. And we do that so that the 4's and the 3's cancel out. That does not make it 0, it just means that 4/3 times 3/4 is 1x, or just simply x. And we know in math, whenever we do something to one side, we always do it to the other. So I'm going to take 72 times 4/3. I can actually do some cross canceling here. 3 goes into 3 once, and 3 goes into 72 24 times, and then 24 times 4 is 96. So 1x equals 96. And notice right here, checking your answer is a great habit to get into. 3/4 of 96 is equal to 72. Let's scroll on down here to the key concept. Please remember to fill in this on your note sheet. The algebraic way, or the symbolic way of explaining the multiplication property of equality and the division property of inequality, or equality, not inequality. And then if I scroll down here, we have a couple more vocabulary words. Inverse operations. Addition undoes subtraction and vice versa, and multiplication undoes division and vice versa. And doing that creates equivalent equations so that the equations have the same solution. Moving on to the next page and part of lesson 8.1, we have some example problems. So example 1, we are going to isolate the variable, again using that vocabulary. When we're solving equations, we're trying to isolate the variable. And when we isolate the variable, we have to use the inverse operation, or the opposite operation of multiplying by 4.2, which is dividing by 4.2. And then when you divide by 4.2 on the right, you get negative 12.5. Okay, and of course, substituting that negative 12.5 back into the equation will verify your solution and whether or not the sentence is true. Let's take a look at the example problems. Letter 1A, make sure to fill these in on your note sheet. And I really appreciate how they use decimals in these problems, because if I were going to give you problems like z plus 2 equals 7, you can do that in your head. So these make it just maybe a little bit more challenging for you to do. So divide by 5.6 so that they cancel out, and divide by 5.6, and we're going to take 19.6 divided by 5.6. So I'm just going to pull up my calculator here. 19.6 divided by 5.6, and I get 3.5. And didn't pay attention to my negative there, so I'll make sure and circle it so I remember it in my answer. X is equal to negative 3.5. And I can check my answer by putting that answer in for X. 5.6 times 3.5 is 19.6. And of course the negative sign makes my answer negative. So the answer to 1A is negative 3.5. For 1B, divide both sides by negative 20.9, negative 20.9, and we have y equaling a positive number because we have a negative divided by a negative right there. Okay, so we're going to take 250.8, I believe it was. Whoops, 250.8. 250.8 divided by 20.9, and that is equal to 12, so y is equal to 12. 1c divided by negative 13.6 divided by negative 13.6. I will make a comment about using a calculator. I'm using a calculator just to speed up the process, and there will be times when you won't be able to use a calculator, and there will be times that you can. In this case, I really want you to get familiar with the process of showing your work, so please include that work shown, and then the trade-off will be that you can use a calculator to speed up the process of getting the answer. But that won't always be the case. So on that one, I've already forgotten my answer. It was 217.6 divided by 13.6, which is equal to 16. So 1c is equal to 16, and I have a equals 16. And lastly, 1d, divide both sides by whatever the coefficient is of x, or in this case z, because I want to isolate the variable. So 13.2, and then we have 323.4 divided by 13.2, which is equal to 24.5. So 24.5 equals z. All right, for example 2, we have a story problem, translating the words in our equation or in our story problem to an equation, and identifying what the variable is going to be. In this case, v is going to be the number of zoo visitors, and then setting up an equation to be able to solve. So let's come down here to example 2, got it. 1 year in-state camping permit for New Mexico state parks costs $180. If the total income was $8,280 during the first day of sales, write and solve an equation of how many permits were purchased. That is our variable. So for this problem, we're going to say P is the number of permits. Make sure you fill this out on your note sheet. And then if I take $180 times the number of permits and set that equal to the total amount of money brought in that first day, I can write and solve an equation to find out how many permits were sold. So 8,280, oops. 8,280 divided by 180 to get a total of 46 permits, and so P equals 46 permits. And going on to the next page here, example 3, there isn't one, I don't believe. Let me scroll up to the top. Oh, there it is, sorry. Solving equations by multiplying. So you can multiply both sides by the same number. Oops, my pen ran out there. multiply each side by the same number. And that could be a whole number, it could be an integer, it could be a rational number like we have right here. 1/4 is rational. Notice how the book shows it. Okay, multiplying both sides by 4. Could you do 4/1? Absolutely. Same thing. Look at B here. Notice that they showed the work the same way I did by multiplying by the reciprocal, right? So they can cancel out and give you 1x. Okay, and could you change -3/5 to -0.6? Yes. It's just probably not as common as showing your work this way. So let's take a look at these examples right down here. For 3A, make sure you get all of these in your book with the notes shown. That'll tell me that you have understood the video and what I'm expecting you to do. I'm going to multiply by -2/1 so that the twos and the ones cancel each other out and we get x by itself. And I'm going to multiply this side by, sorry, there's not enough room here, -2/1. And -2 times 7 is -14. So -14 equals x, and we could check that out by plugging in -14 right here. -1/2 times -14 is a +7. Okay. For 3b, we're going to multiply by 7/6, cancel it out, multiply by 7/6, and be sure to cancel if you can. It makes the multiplication a lot easier. 3 goes into 3 once, into 6 twice. -1 times 1 is -1. 2 times 2 is 4. So m equals -1/4. On 3c, multiply by 3/1, so the 3's and the 1's cancel out, leaving the n by itself, and multiply by 3/1 to get -27. And finally, 3d, multiply by 7/2 and multiply by 7/2, and we get y equals -7/8. Again, pay attention to those negative signs. Hopefully that's enough to get you through examples or through Lesson 8.1 homework. Make sure you take the video lesson quiz and have all the notes filled in, and then watch those additional tutor videos if you need it. In Lesson 8.1, we were solving what's called one-step equations because it only required one step to find the answer. So we saw things like -3/4 x equals 12. And we had to multiply, in this case, by the reciprocal, which is -4/3, and then -4/3. In this case, we get an answer of x equals -16. That's called a one-step equation because it only required one step. Well, in Lesson 8.2, we have two steps. And the traditional two-step equation is going to have you doing things in this order. The first step will be to add or subtract a number, and the second step will be to multiply or divide. Okay, and in the one-step equations, the only thing we did was multiply or divide, but you can also add and subtract with one-step equations. But typically, a two-step equation is going to have you add or subtract and then multiply or divide. And I'll show you what that means by taking a look at the examples. So the definition of a two-step equation contains two operations. And use those inverse operations. Remember, those inverse operations undo things so that we can isolate the variable. So on example 1, remember that I told you that your first step is probably going to be to add or subtract. In this case, we're going to subtract the 9 because 9 minus 9 is 0. And we don't write a 0 here because that just clutters things up. So we do, however, take 33 minus 9 to get to 24. Then we have 3a equals 24, and when we divide by 3, remember the second step I told you would probably be to multiply or divide. 24 divided by 3 is 8. Okay, and this vertical method, that's that method that I prefer because that's the way I was taught. But there is a horizontal method, and you can make your decision on how you like it or not. But that just has you showing that -9 going horizontally versus vertically. But At any rate, as you do more and more two-step equations, you can decide what's the best fit for you. I will probably stick to what I know best, which is to show it the vertical way. And my first step here to isolate the variable x is going to be to subtract 1. Again, I don't put a 0 down here because that's not necessary. I'm going to say 25 minus 1 is 24. And we bring down the 6x, divide by 6, divide by 6, x equals 4. And on number 1b, plus 5 plus 5. 4x equals negative 28. And divide by 4, x equals negative 7. Please have all of this work shown in your notes, just so I know that you're following along and you know the proper way to show work. In the next example here, at the top of page 334, we have another type of two-step equation, and then this one has a coefficient of 1/5, and we're going to have to multiply to get rid of or to isolate the variable. So again, two-step equations have 2 steps. The first step is probably, well, most of the time going to be to add or subtract a number. In this case, we're adding 12 because it's minus 12. And to undo that, we use the inverse operation, which is addition. Right now it's 1/5 times p. The opposite is to divide by 1/5. And that's why you see that 5 out front, so we can isolate the variable p. And then when we take 5 times 32, we get 160. Notice on this one they showed it the horizontal method. I'm going to show my work here the vertical method. So minus 15, and we get negative 7 equals 1/3 n. Multiply by 3 over 1, multiply by 3 over 1, and n equals negative 21. On 2b, plus 3, negative 1/6 x equals 5. Multiply by negative 6 over 1, and multiply by negative 6 over 1, and we get x equals negative 30. In example 3, we are going to have another type of two-step equation, and you might just think, well, the variable's already isolated. All I have to do is add 15 to both sides. Well, that is true. We're going to start by adding 15 to both sides to get 59, but notice we have a negative b equals 59. We never want to know what a negative variable is, so we're going to divide by negative 1, because negative 1 divided by negative 1 is a positive 1, and we're going to get b as a positive value. So when I divide 59 by negative 1, though, I get negative 59. Let's do another one of those. We're going to add 4.3 to both sides. We're still going to do the two-step operation. The first one's usually going to be to add or subtract. So add 4.3. And 6.5 plus 4.3 is going to be negative 2.2 equals negative n. And when we divide by negative 1, those negatives cancel out. Divide by negative 1, we get n equals positive 2.2. All of those basic skills of negative and positive numbers are coming back, and that's why it's really important to keep on practicing that. So on example 4, we actually have a combining like terms. So going back to last chapter where we're combining like terms. So I would technically call this a 3-step equation because there's 3 steps. Step number 1, combine like terms. Okay. Step number 2, add 27 to both sides. And then step number 3 is to divide by 3. So I call that a 3-step equation. Let's go down to the bottom here. 4a, negative 9c plus 3c is negative 6c. We have that 4 there, so I'll do plus 4 equals 58. Minus 4 negative 6c equals 54. Divide by negative 6. Divide by negative 6. C equals negative 9. Common mistake here. I'm going to write this one off to the side. Negative 6c equals 54. See, a lot of students do plus c, sorry, not plus c, plus 6 plus 6, and they say c equals 60. Well, all you have to do is come back and plug it into the answer to see if it works. So let's put 60 in for c over here. Negative 6 times 60 is negative 360. And negative 360 plus 4 is definitely not 58. So use that to check your work, because very common mistake to see that minus coefficient, that negative coefficient, and thinking that you're just going to add it. Negative 6 is being times by c. So the opposite operation, or the inverse operation, is to divide by negative c. In 4b, we have 0.4m and 0.2m, which is 0.6m minus 2 equals 3.4, plus 2 plus 2, we get 0.6m equals 5.4, divided by 0.6, divided by 0.6. That's the same thing as taking 54 divided by 6 if I move those decimals over. So m is equal to 9. Lots going on here in lesson 7.2. Make sure you take advantage of the video tutors and also Google Hangout. It takes 2 minutes for me to explain something if you're stuck, but it takes 24 hours, sometimes 72 hours before I see you face to face, so you have to utilize your resources. Google Hangout is one, asking a teacher is another. Emailing me is fine, but sometimes you don't get that answer right away, so make sure that you take advantage of those resources. One problem-solving strategy is to write equations, and that's what lesson 8.3 is all about, writing an equation. It's not my most preferred way to problem solve. I like to draw pictures and make tables and charts, but solving problems by writing an equation is a very useful tool, and you get better at it by doing it more. So that's what I continue to strive to do, is to get better at writing equations so that I can be a better problem solver. And it's basically translating story problems into sentences, math sentences, by using variables and numbers, equal signs of course, and then operations. So we are going to be doing that during lesson 8.3. Example 1, Zach has 6 shirts. This is 4 less than twice the number of shirts n that Xavier has. So Xavier has n, twice that is 2n, and 4 less than that would be minus 4, and that's equal to 6 total. Okay, 8 more than, 8 plus, the quotient of a number y and negative 3. Quotient is a division problem, looks like that. And then is, the word is means equals, and then negative 24. Jeremy has 13 baseball cards, 7 more than 1/5 the number m. 1/5 of the number, the word of, well, there's no of here, but 1/5 the number n is going to be multiplication, so that's where the 1/5 m comes from. And then 7 more is 7 plus that amount, and that equals 13. So let's work on that with examples 1a, b, and c. 4 more than, 0.3 times the number x, 0.3 times the number x. 4 more than that, you could put 4 plus, or you could do plus 4 on the other side. It really doesn't matter because the commutative property is telling us we can do it in any order here on either side there. And then the word is equals, and then negative 26. For 1b, Hannah has 24 stickers. This is 6 less than twice the number of stickers n that Molly has. So twice the number of stickers Molly has is 2n, And then 6 less than that would be minus 6, and then equals 24. On some of these you have to work backwards because even though it says 6 less than, you're not going to write that as 6 minus 2n because that's going to give us a completely different answer. If I ask you, what's 6 less than your age? 6 less than your age. Are you going to take 6 minus your age? No, you're going to take 6 less than your age, so 12 minus 6. So especially the operations that are not commutative, like division and subtraction. Those are the ones you have to pay a little bit more attention to. Finally, 1c, the quotient of a number n and 7. A quotient is going to be shown like this in algebra. We're not going to use our division symbol like that or that. Quotient of a number n and 7 increased by 6 is equal to 12. Okay, so we're doing a form of translation here, not from English to Spanish, but from words to math symbols. In example 2, we're going to have more of the same thing by translating words into symbols. In this case, Juan's father was 29 when Juan was born. And then the sum of their ages is 53. So this is a little bit more complicated because we have to, first of all, say what x is going to be, in this case, Juan's age. And then Juan's father was 29. So Juan plus 29 would be his father's age. And when you combine both of their ages, the sum is going to be equal to 53. So that's how we get our equation. And then we combine like terms, 2x's gives us 2x, the plus 29 equals 53, minus 29 from both sides, and then divide by 2. Let's take a look at one of those examples. Deisha saved D dollars last month. This month she saved 8 more than 3 times the amount she saved last month, and the total was 141. So we're going to just say D is last month. And then this month, it's going to be 8 more than 3 times what she saved last month, which was D. So that's what this month equals. Together, she has $141. So we're going to take what she had last month, D, plus what she has this month, 8 plus 3D, and set that equal to 141. This is a 3-step equation because the first thing we're going to do is we're going to combine like terms. 3D plus 1D is 4D, plus 8 equals 141, minus 8 from both sides, and we get 4D equals 133. Divide by 4, 133 divided by 4 is 33.25. So $33.25 is what she saved last month. Okay, let's scroll on down here to the next example, example 3. Logan collected pledges for the charity walkathon. He received a total of $65.50 plus $21.75 for every mile that he walks. So what we have is $65.50 no matter what. Oh, I'm sorry. Take that back. $65.50 was the contributions, and then take away what he earned per mile to find out what he had walking in miles to get that extra amount there. So 65 plus 21.75 m equals 370, minus 65.50 from both sides, and then divide by 21.75 to find out that he walked 14 miles. So if I scroll down here and take a look at the example problem, Jasmine bought 6 DVDs at the same price. The tax was $504, and the total was $85.74. And if I gave you this problem without asking you to write an equation, you probably would take $85.74 minus $504 and get $80.70, and then divide that by 6 CDs to find the price. And I understand that because that's how I would do it. I just want you to get really good at writing equations because that's what algebra is all about. And the more you practice, the better you'll get at that strategy. So the way this would look, basically what you just did up here in algebraic terms is each CD cost a certain amount. And we know that he bought or she brought 6 CDs, so we're going to say 6x. And then we're going to add in the tax, which is 504, to get us to the total amount, which was 85.74. And we essentially do the same thing we did here. We're going to take away 504 from both sides. Whoops. And we get 6x equals 80.70. Divide by 6, divide by 6, the exact same thing we did up here. And the price of each DVD, X equals 80.70 divided by 6 to get 13.45. 13.45 is the price of each DVD. Okay, nothing wrong with doing it this way. Just really want you to get in the habit of translating words to equations and get the same answer, but push yourself to try a new strategy, just like I'm trying to do myself. I think that's it for lesson 8.3, and good luck on the homework. Again, don't forget you always have resources. You have the check your understandings that you do for each lesson. You even have this resource, which we haven't explored too much, but the e-help. You also have a Google Hangout. You also have video tutors that you can watch, all sorts of ways that you can really make sure you understand something instead of waiting until I come the next time or waiting for something else to happen. Use your resources and make sure you understand. For lesson 8.4, we're solving more types of equations, two-step equations, but in the format of P parentheses x plus Q equals R. And if I scroll down here and take a look again at an example problem, in this case we have 4 parentheses x plus 3 equals 28. Similar to that example at the top, P equals x plus Q, P parentheses x plus Q equals R. It's in the same format there. So I actually might do this problem a different way, but I will show you that after I go through the way the book shows. In this problem, we are going to isolate, first of all, the variable in parentheses here by dividing by 4. That takes care of the coefficient. And again, dividing both sides by 4 to make it equal on both sides. Then what we're left with is the parentheses x plus 4, and then we can take away 3, and get the answer. I might draw on our knowledge of the distributive property to make this actually into a 3-step equation. I don't know which is better, 2 or 3 steps, but I might say 4 times x is 4x, 4 times 3 is 12, and that equals 28. And then when I minus 12, I get 4x equals 16. Divide by 4, x equals 4. But since that is natural to me as a way to solve that problem, I'm going to push myself to try to solve it a different way, which is the way the book shows in the example. So I'm willing to learn new methods and new ways to do those problems. So in B, notice to get rid of the 3/5, multiply by the reciprocal, 5/3, and then add 6 to both sides. So at the bottom here, let me go ahead and turn my solutions off so I'm not distracted by that. The first thing I will do to isolate my variables to get rid of the coefficient, so divide by -2. And so I get 11 equals y minus 3 plus 3 plus 3, 14 equals y. On 1b, divide by 3.2, divide by 3.2, and I get x plus 3.7 equals 4.8 over 3.2. Let's just see here, 48 over 32, and 8 goes into 48 6 times, 8 goes into 32 4 times, and 6/4 is the same thing as 1.5 or 1.5. And then I'm going to minus 3.7 minus 3.7 to get x equals negative 2.2. Go ahead and write those down on your note sheet, and it looks like this one I might have gotten incorrect. Oh, that's why, because negative 11 is what I should have had there. Negative 11 plus 3 is a negative 8. So I forgot a negative. Even your teacher does that. So just get those down, and if you need more examples like that one, you can check out the video tutor. And going on to example 2 on page 348, we are looking at the same type of problem, only in Word format and having to translate that out. And so check through the example 2, and then we'll do the one right here together. Natasha buys 5 bottles of orange juice, and she has coupons for 65 cents off the regular price of each bottle of the juice. After using the coupons, the total cost is $6.20. What's the regular price of the orange juice? So X is going to be equal to the regular price of the orange juice. So X dollars is the price of OJ bottle. And if we knew the regular price of the OJ bottle, we would take away 65 cents because she has a 65-cent off coupon for each bottle. And that's the price of one bottle, but we knew she bought 5 bottles of the juice right there. And then we know she spent $6.20. Okay, so when you're translating from a word problem to an equation, you're really just working in smaller chunks with the information you know. Don't let that scare you when there's words and you have to translate them, because it really is just taking it apart piece by piece. So if I divide both sides by 5 to get rid of that coefficient, I get x minus 0.65 equals 1.25, $1.25. And then if I add on the 65 cents, I get x equals $1.90. Where did my extra penny come off? $6.20 divided by 5, $1.24. There's my mistake right there. There's my extra penny. That should be $1.24, not $1.25, which makes it $1.89 for the right answer. And looks like they did decide to show you that other strategy of solving equations in the form of p parentheses x plus q equals r by using what I showed you, which is the distributive property. So same types of problems, just different strategies. So in this case down here at the bottom of page 348, 5 times g, 5 times negative 3 gives us 5g minus 15 equals 11, plus 15 plus 15, 5g equals 26. Divide by 5, g equals 5.2. Double check my answer there. 5.2 is the same thing as 5 1/2. For 3b, 9 times negative 3, 9 times x is negative 27, plus 9x equals negative 2, plus 29, plus 27, plus 27, 9x equals 25, divide by 9, x equals 2, and that would be 18. So 7/9. Let's see here, 2 and 7/9. Yep. All right. So solving two-step equations in the format of P parentheses x plus q equals r. A couple different strategies there for you to consider as you work on your homework for this lesson. And make sure you get your notes done, and you also take your self-check and video tutors if you need extra help. Try this e-help step-by-step solution for those problems as well. For lesson 8.5, we're talking yet again about a different type of equation. We went through one step and two steps and even touched a little bit on three steps. And this one type of equation has variables on both sides of the equation. So what we have here is x's on both sides, or y's on both sides. And so not only do you have to get the x's to one side of the equation, but then you also have to combine like terms, and then again, still isolating the variables, the very top priority when solving equations. So a couple ways to do this type of a problem is to show it with tiles. And this just shows 3 x's on the left-hand side. There's the 3 x's. There's 1 x on the right side, and there's 8 1's. And if we get rid of this one, if we take away one of those from both sides, we are left with 2 x's on the left and then the 8. And then we can find out what 1x is by dividing by 2. Okay, so this is just a really neat way to visualize doing equations with variables on both sides, or equations whatever type of equation you're doing. It's just a great way to model. So I'm going to try to do that here on these examples. I know it doesn't ask you to do the tiles, but again, I'm stretching myself into thinking about different methods, and I think it's important to do that. So 1, 2, 3, 4, 5, 6, 7 x's on the right equals 1, 2, 3, 4, 5, and then 1, 2, 3, 4. I'm going to change my pen color here, and I will cross off common x's. So there's 5 x's here that I can get rid of. And if I get rid of 5 x's here, I'm left with 2x equal to those 4 individuals. So 1x is equal to 2. Let's do that same problem by showing the work algebraically. The first thing I did was take away 5 x's from both sides, leaving myself with 2 x's equaling 4. And then I divided it into 2 different groups. And so each group has 2 in it. So or x equals 2. Same answer. Okay, let's try 1b. Same strategy of showing the bars. So 1, 2, 3x minus 2. I'm just going to put 2 little dots here for -2 equals 1x. Okay, so I'm going to take away 1x here and take away 1x here. So I have 2 x's, and then -2's equals nothing. But to isolate the variable, I've got to get anything on the other side that doesn't go with the x's. So I'm going to add those two to this side, to the right side, giving me 2 x's equals the 2 dots there, +2, and dividing those into 2 separate groups, I get x equals 1. Let's try this the algebraic way. Minus x minus x. 2x minus 2 equals 0. Plus 2 plus 2. 2x equals 2. Divide by 2, divide by 2. X equals 1. Okay, I don't care how you show your work on those two problems. I guess I would encourage you to show both methods so you kind of know that those are both available. But I will probably tend to always go with this method because that's what's familiar to me. but I do like the idea of showing work in a visual manner as they've done here on lesson 8.5. At the top of page 357, we have example 2, going through, again, variables on both sides, and this time we have some rational numbers, some fractions to deal with. And when we do that, we have to worry about common denominators and so forth. So look through those steps of how they did that in the example, and let's take a look at examples 2a and 2b. Notice here we have 2.1x on the left side, and we have 3.1x on the right side. You can either minus 3.1x minus 3.1x, or you can minus 2.1x and minus 2.1x. Okay, either one is right. I just like to use positive numbers, and so I'm going to minus 2.1x from both sides. What's 2.1x minus 2.1x? 0. So all I have left on the left side is 3 equals 3.1x minus 2.1x is 1x. And then that minus 2 is still there. To isolate the variable, I'm going to get rid of that negative 2 by adding it to both sides, and I get 5 is equal to x, or x equals 5. Okay? And I will just double check my work there. There's the 5. On 2b, I have 1/2 p and 3/4 p. I am going to minus 1/2 p because I like to deal with positive numbers, and 1/2 p minus 1/2 p is 0, so I'm left with negative 15 equals 3/4 minus 1/2 is 1/4 p, and then that minus 3 is still there. Plus 3 plus 3, and I get negative 12 equals 1/4 p. Multiply by 4 over 1, multiply by 4 over 1, and I get 4 times negative 12, which is negative 48. So when variables are on both sides, it's pretty nice when those numbers are whole numbers, but you also have to remember dealing with decimals and fractions as part of it too. So paying attention to details on those is going to be really important. I still make those mistakes, and I've been doing this for a long time. On example 3, we have another equation that needs to be translated to algebraic equation. So we're going to take it piece by piece here. A personal trainer has a one-time fee of $60 and then $25 for each individual session. And then the fitness club charges $450 for the yearly fee plus $10 for each session. Write and solve an equation to determine for what amount of sessions the cost will be equal. So there's the equal sign. On the one side we have the $60 plus $25 for each session, and then on the right we have the fitness club that has the $450 fee plus $10 per session. Variables on both sides, so it looks like they are choosing to minus 10s. You could minus 25s, but again, it's nicer to work with positive numbers. So 25s minus 10s is 15s, and then you get the 450 minus the 60 to get the numbers on the right side. And again, you can follow this all through your notebook and watching that, how that progresses. And I will spend my time down here going to the got it problem to make sure that you understand that. Redbird Cruises is $85 a day and a one-time fee of $75. That's $75 plus $85 per day. Okay? And then King Cruise has $100 per day and a fee of $30. So that's going to be the same as $30 plus $100 times how many days. Now, if you're going to only do it for one day, Redbird Cruises for one day would be $85 plus $75, which is $160. And one day for King Cruises would be 1 day for $100, that's $100 plus the $30 fee is $130. So if you're only going to rent it for 1 day, it looks like King Cruises is the better deal. But it says write and solve an equation to determine for what number of days the cruise will be the same. So here it is. It's equal to each other, and we're going to solve that by getting the variables to both sides. You could minus 100d from both sides, but I'm going to minus 85d, so I have a positive number. 75 equals 30 plus 15d minus 30 minus 30, and we get 45 equals 15d. Divide by 15, divide by 15, d is equal to 3. So after 3 days, it's the same price. Okay, so let me see here, check my work. Yes, 3 days. So you should have all of these things written down in your notes for lesson 8.5. Okay. Could you have solved that problem a different way? Absolutely. But again, our focus is on writing equations from word problems, practicing that problem-solving strategy of using equations. Even though it might not be your favorite or your best strategy, it is worth understanding how to use it so you can become a better mathematician and problem solver. For lesson 8.6, we're talking about inequalities. And so it's really important that you understand that there's a difference between equations and inequalities. Equations always have an equal sign, and inequalities always have not equal signs. So the prefix in is going against what they are. So inequalities is not equal signs. And what does not equal signs mean? Well, it's these symbols: less than, greater than, less than or equal to, greater than or equal to, and even not equal to is an inequality. So for inequalities here, make sure that you have all of those inequalities written down. And the basic idea here is that equations are usually going to give you just that one answer of x equals 2. Whereas inequalities like x is greater than 2, there's lots of numbers that are greater than 2. There's an infinite number of numbers that are less than negative 7.5. Okay, so kind of get that in your head too, that equations we've been solving for one value of x, whereas inequalities have multiple answers. And another way to show that answer is on a number line. So if the answer is x equals 2, that's pretty easy. Here's 0 on the number line, here's 1 on the number line, here's 2 on the number line. The answer is x equals 2. But if we have an answer like x is less than negative 7.5, let's just do some estimating here. Here's 0, and we'll just say this is negative 7.5. Okay, well, x is less than negative 7.5 means 7.5 is not an answer, which is an open circle, meaning that's not an answer, but every number to the left is an answer. So we're going to draw a little arrow, and sometimes teachers want you to go up and to the left like that, showing that all the answers less than negative 7.5 are, in fact, answers. So let's take a look at the lesson at 8.6. Example 1, DVD costs more than $15. DVD costs more than $15. If it said the DVD costs $15, it would be D equals 15. But more than is the greater than sign that we're going to use for the inequality sign. A dog weighs less than 50 pounds. Less than 50. If the dog weighed 50 pounds, it would be D equals 50, but it's less than 50. Okay? So for example, 1A and B, Amelia sold more than 40, M is greater than 40. Gino sent less than 35 texts, T is less than 35. Pretty straightforward there. Let's take a look at page 362 at the top of the page. We have a really nice chart there for you to fill in on your note sheet. Please make sure you get those items filled in, and gives you some different ways to pronounce those. Okay, so it's greater than or equal to, is no less than, is at least, is at most, is no more than. Those are all great words to help us translate story problems into the inequalities. For example 2, your age is at least 18 years. This means you're at least 18, but you could be older. So it's A is greater than or equal to 18. I'm going to turn my answers off here and look at examples 2, the got it section. A student must have at least 10 hours during driving time to pass the course. At least 10 hours, so it has to be greater than or equal to 10 hours of driving time. And the variable can be anything you want there, okay? These are called open sentences with variables. So inequalities with variables are called open sentences. When the variable is an open sentence is replaced with a number, then you can either say it's true or false. So here's an open sentence or a inequality with variable, okay? As soon as I put in a number for t, like the number 12, it becomes true or false. Is 12 greater than or equal to 10? Yes, it's true. Okay, if I plug in the number 5, is 5 greater than or equal to 10? No, that becomes false. Okay, scroll on down to example 3. For the given value, state whether it's true or false. So we're just plugging in numbers, something we've done quite a bit of during first semester. We've been substituting in substituting in values for the variable into mostly expressions. Now we're substituting it into inequalities. And so same type of thing we've been doing, only we're using inequalities this time. So this time we're going to put in x for the value of x. 3.9 plus 6 is 9.9. And it is true that 9.9 is less than or equal to 12. So we're going to say the sentence is true. For 3b, we're going to put 4/3 in for y. 4/3 minus 1/3 is equal to 3/3. Is 3/3 less than 1? 3/3 is 1. 1 is not less than 1, so this is false. The sentence is false. If there would have been a little line underneath there, we could have said true because 1 is less than or equal to 1. But in this case, it wasn't there, so we have to say false. On the next page here, page 363, we have another couple of examples to go through. For example 4, we're going to be graphing. And this is where it's really important for you to understand the difference between an open circle and a closed circle. So make sure you get this in your notes for lesson 8-6. If it's a less than sign or a greater than sign, that's going to be an open circle. And less than or equal to and greater than or equal to is going to be a closed circle. So A is greater than 6, open circle at 6, arrow to the right. Some teachers might also have you go up and out so they can actually see the line in which direction it's going. B is less than or equal to -1. That's a solid filled in dot with an arrow going to the left. Is it important for you to put all of these numbers? No. I just like usually a reference point. A 0 is nice, and then one other number on each side. X is less than 5. So the way we're going to do that is put a 0 here, a 5 here. It's an open circle because there's not a line underneath that. So an open circle with an arrow going to the left because those numbers are less than 5. Greater than or equal to -2. Here's my 0. Here's my -2. That's going to be a closed circle with an arrow going to the right. And finally, x is greater than 0. I might just put -1, 0, +1. That's an open circle with an arrow going to the right. Lastly, example 5, it says to write an inequality. So that involves having a variable, x, y, z, whatever you want. The arrow in this case is going to the right, so that is greater than. It's also a filled in circle, so I'm going to put that little line underneath. And what number is that where the dot is? It's at a -3. That's my answer. For 5b, start with the variable. The arrow is going to the left, so that's less than. The circle is open, so I'm not going to put the line underneath. And the last step is to put that number that it's on, which is -2. Hopefully that's enough to get you through lesson 8-6. Pretty straightforward, just some new things to consider when we're talking about inequalities. Eight seven is on solving inequalities, and as I mentioned in the last portion of the video, we have equations with equal signs, and that gives us answers like x equals 2. And when we have inequality signs, we have answers like x is greater than 2 or x is less than 2. When we solve equations, we do the opposite operation or the inverse operation, so we can isolate the variable. So we have 3x equals 9. Divide by 3, divide by 3, x is equal to 3. And when we have inequalities, it's the same exact thing. We do the inverse operation to isolate the variable, except that when we have our answer, it's not only x is 3, it's x is greater than 3. So any number greater than 3 would make this inequality true. For example, the number 4. What's 3 times 4? 3 times 4 is 12, which is greater than 9. What's 10? X is equal to 10. 3 times 10 is 30, and 30 is greater than 9. So one answer, multiple answers. Kind of the main thing you need to understand when we're talking about the difference between equations and inequalities, in addition to the different symbols that are used in both situations. So let's take a look at 8-7, the examples. Okay, again, we have a key concept here. We have words and symbols, and then some examples. When you add or subtract the same number from each side, the inequality remains true. So many ways in math that applies. Do the same thing to both sides or both components. As long as you're treating everyone fairly, everything is going to be just fine. So let's take a look at number 1. We have a regular inequality. Notice it's not an equal sign, it's an inequality. We're still going to subtract 5 from both sides and get our answer. Okay? And we can check our answer by picking a number greater than 7. Let's pick the number 10. 10 plus 5 is 17. Is 17 greater than 12? Yes, it is. Look what happens when we pick the number 7. What's 7 plus 5? 7 plus 5 is 12, but 12 is not greater than 12. So 7 is not an answer, which is why when you're drawing your inequality on a number line, okay, the number 12 has not the number 12, I'm sorry, the number 7 does not have a filled in circle. It's an open circle, and then every number to the right also works. So that's the meaning behind the open circle and the closed circle. If there was a little line underneath there, then it would be filled in. So it's just important to remember those little details. On 1a, minus 10, minus 10. Y is less than -7. Minus 7, x is greater than or equal to 3. Just turn my answers on really quickly to check those, and we are good. For the next example, we have some more inequalities to solve, and it says to graph the solution on a number line. So we are still going to solve like normal, like we have been, except for we are going to solve that and then show it on a number line. So we're going to use a closed circle with an arrow going to the right, since the solution for that practice problem on the top of page 368 was b is greater than or equal to 4 1/3. Let's do a couple example problems together. Let me turn the answers off here. And g plus 7 is on the right-hand side. So this is where it gets a little bit confusing for some students. Still no problem with doing the first step, which is -4 is greater than or equal to g. Well, essentially what that means is that g is less than or equal to -4. So think about that for a second. We're looking at numbers that are less than or equal to -4. So let's say here's -4. -4 works, but then so does every number to the left, which would be numbers like -5, -6. Let's just check and see if that works. Put -5 in right here for g. -5 plus 7 is 2, and 3 is greater than or equal to 2. Let's try -6. -6 plus 7 is 1, and 3 is greater than or equal to 1. So going back here, 3 is greater than or equal to g plus 7. No problem with this step, but when you get to -4 is greater than or equal to g, sometimes that makes students confused, or in my case, I just like to have the variable first. So I'm going to put the g there, but I'm going to flip my sign around to make sure that I didn't flip the sign. Flip the sign there to make sure that I include the numbers to the left. What if I forget to and just say, okay, well, one of the solutions, and I put my arrow going to the right instead. What's a number to the right of -4? Let's just say the number 1. But when you put 1 in for g, what's 1 plus 7? 1 plus 7 is 8, and 3 is not greater than 8. And so that just tells you that the numbers to the right are not the correct answer. So just be aware of that. On 2b, I'm going to minus 5 sevenths. b is greater than 1 and 2 sevenths. Don't let those fractions freak you out. Just go ahead and estimate on your number line here. Here's 0, here's 1, here's 2, and 1 and 2 sevenths is somewhere right there. Let's just mark that as 1 and 2 sevenths. There's no line underneath, so I'm not going to fill it in, but I am going to go up and to the right to show all of those numbers to the right of 1 and 2 sevenths. Okay, and here is another key concept, that when you multiply or divide by an inequality by the same positive number, it's going to remain the same. So just like last time when we add or subtract a number to both sides, then you're going to have the same principle here. It's going to remain true if you do the same thing to both sides. It also works to multiply and divide by the same number. So let's take a look at example at the top of page 369. I think we're on example 3 now. And let's see here. The top here we have a story problem of Macy making her 7 friends a bracelet, and in addition to the charm she needs a package of wire for the bracelets, and the wire is $6. She does not want to spend more than $45, so we have C, the cost of the bracelet, and 7, the number of friends. Add in the amount of wire, and then she does not want to go over $45, so less than or equal to. When you subtract 6 from both sides and then divide by 7, we find out that each person cannot be spent more than $5.57. Okay, so just again, the theme throughout this chapter is not only being able to solve problems like this, but problems given to you in this manner, story problem, and then translating it. So for 3A, we have Alfonso that works for a lawn service company. He takes 3/4 of an hour to mow a lawn, and if he works more than 8 hours, he gets a half-hour lunch. Write and solve an inequality to find out the number of lawns he can mow if he works at least 14 hours. So it says that we don't know the number of lawns he can mow. Okay, so X is going to be the number of lawns. And we know that each lawn takes 3/4 of an hour to mow. Okay, so I'm just going to change that to 0.75x. And if he works more than 8 hours, he gets that half-hour lunch. So we have to add in 0.5 for his lunch. And then it says if he works at least 14 hours. So you can go over 14. So I'm going to say greater than or equal to 14. If we take away that half-hour lunch, that means we have 0.75 times the number of lawns greater than or equal to 13.5. And if we take 13.5 divided by 0.75, we get 18 lawns. So that means that he can mow 18 lawns. 0.75, 0.75, x is greater than or equal to 18. Let me just turn my answers on to make sure that that's what we got there. And yes, 18 laws, the answer for 3A. For 3B, we have Kiko prepared 28 bags of granola. She also received a $10 donation. Write and solve the inequality to find out the price she should charge for each bag if she wants to raise at least $115. So she wants to have at least greater than or equal to $115. So we have 28 bags of granola times the amount of money each bag costs, plus the $10 donation that she received, and we want that to be over $115. So if we take away the $10 from both sides, we get 28x is greater than or equal to 105. And if we divide both sides by 28, we get x is greater than 105 divided by 28, which is $3.75. So she should charge at least $3.75 if she wants to make that $115 goal. So let me just erase that and make sure that my answer was correct. 28p plus the $10 greater than or equal, and then when you solve it, $3.75 is the answer. Okay, lastly, this key concept's the one that really trips students up, because when you multiply or divide by a negative number, then the inequality symbol has to be reversed. And it's not just because it's to make it really confusing for students, it's because if you don't flip it, then the answer does not work out. And when you substitute numbers in, it doesn't make the inequality true. So if I scroll over here, let's look at an example here. Top of page 370. There's some explanations there for you to work through, but I'm going to take a look at example 4. So negative 5 times x is less than 45. And the same thing goes. We're still going to divide by negative 5, and we get that negative 9. But when we divide by a negative number, we flip the sign, and we, in this case, have x is greater than x is greater than negative 9. And again, that's not a rule to make it super confusing. It's because, let's just say we didn't flip the sign. We just left it x is less than negative 9. What's less than negative 9? Well, negative 11 is less than negative 9. And if we put negative 11 in for our x value here, negative 5 times negative 11 is a positive 55. And 55 is not less than 45. Let's pick a number that's greater than. That's our answer. X is greater than negative 9. Let's pick negative 5. Negative 5 put in for x here is negative 5 times negative 5, which is 25. And 25 is less than 45. So, key idea here, when you divide or multiply by a negative number with inequalities, that sign has to flip. So in this case right here, add 2, multiply by negative 8. Notice it flipped from greater than or equal to less than or equal to. And again, that's not just some made-up rule. It's because, let's pick a number greater than 48. Let's just say 56. Let's pick 56 and put that in here. What's 56 divided by negative 8? That would be negative 7. Negative 7 take away 2 more is negative 9. And negative 9 is not greater than negative 8. Let's pick a number less than 48. Let's pick the number 40. Okay, what's 40 divided by negative 8? 40 divided by negative 8 is negative 5. Negative 5 take away 2 is negative 7, and negative 7 is greater than or equal to negative 8. Key concept here, you really have to make sure you understand example 4. Okay, let's take a look right here at negative y over 4. I'm just going to multiply by negative 4 because then the negative 4's cancel out. I'm going to multiply by negative 4 here and get y is greater than negative 12. Okay, flip the sign when you multiply or divide by a negative. On 4b, I'm going to divide by negative 2, divide by negative 2. Negative 3.5 is less than or equal to f. Okay, because we divided by a negative number, we're going to flip the inequality sign. Okay, make sure to do your homework check and make sure you understand how inequalities work when you're solving them, especially when you multiply or divide by a negative number.